Hello, this is Pete from Essex Ham with a quick module for those studying our Foundation online course. In the Technical Basics module, you'll be required to calculate power, current and voltage. For this, we use our triangle, PIV, as we've discussed in Module 2. It's all very well knowing the formula, PIV, and knowing the triangle, but it's how to put it into practice that matters. In this module, we'll look at a practical application for that formula. For this, I'm going to take our trusty desk lamp. It's mains powered, has a power switch, and there it is. If you look closely on the inside of the lamp, you'll see it has a power rating. The light bulb that we put into this lamp has to be a maximum of 40 watts. Let's break it down and look at the circuit diagram for this desk lamp. You can see it's powered by 230 volts mains. There's a fuse in the circuit, an on-off switch, and the lamp or the bulb itself. A fairly straightforward circuit. First off, let's look at what the fuse actually does. The fuse is inside the main socket, and here you can see the fuse, which is connected to the live part of the main socket. Power comes in through the socket in the wall, through the fuse, and off to the live wire of the device. If you were to take a look inside a fuse, all you'd find is a very thin piece of wire. On the screen here you can see some of the more common sizes of fuse available. Today most new equipment either comes with a 3 amp fuse or a 13 amp fuse. You may see some 5 amp fuses in older equipment. Again, looking at our see-through fuse, the point is if the current exceeds the value of the fuse, the bit of wire inside the fuse melts, thus breaking the circuit. So how do we calculate which fuse we need to use? For this, we're going to use our triangle. At the top of the triangle, P for power, which is measured in watts. Bottom left, you have the current, I, and bottom right, V for voltage. Now in this case we want to calculate the current, which is measured in amps, because fuses are in amps, so we cover the I. That leaves us with P over V. So let's look at the values. Now we know the power is 40 watts. From the little sticker on the inside of our lamp. And we know the UK mains voltage is 230 volts. So we want 40 watts divided by 230 volts. For that we turn to our trusty calculator. And we calculate 40 watts divided by 230 volts. That gives us the answer of 0.17 amps. So there we go, the current 0.17 amps. So it's less than 1 amp. In that case, we're going to use the lowest value of fuse available, which in this case is 3 amps. So a 3 amp fuse will blow if the current exceeds 3 amps. Now you could put a 13 amp fuse in there, but it won't be as safe because the current would need to exceed 13 amps before it would blow. You want the lowest safe value to keep yourself safe, 3 amps in this case. Hopefully that was pretty straightforward. Let's give you an example to work on yourself though. Let's look at the kettle. So again, a kettle is a fairly simple circuit. It takes in power, it has a switch, a fuse and a heating element. Looking at the bottom of my kettle, I can see it's rated between 2.5 and 3 kilowatts. So for the sake of the maths, we'll assume the highest value of 3000 or 3 kilowatts. So time for you to do this yourself. Get yourself a pen and paper. And we have 3000 watts and the UK mains voltage of 230 volts. So what is the current that our kettle draws and what fuse should we use? Time to press pause on the video and use your paper and pen to work out the answer. Okay, let's see how you did. So you should have taken our triangle, PIV. We want I, the current, so we cover up the I, and that leaves us with P over V. So we know P, the power, is 3000 watts, or 3 kilowatts. We know the voltage is 230 volts. So we want 3000 divided by 230. Let's turn to our calculator. 3000 divided by 230 is 13. So 13 amps current. That's a fairly simple one because the fuse that we're going to need for this one is our good old 13 amp fuse. The kettle needs 13 amps to operate, and if the circuit goes over 13 amps, the fuse will blow, keeping us safe. There you go, that's a simple look at the formula PIV, power, current and voltage. We hope that's been a help, and best of luck with the rest of your studies.